You can see the screen share, yeah, on the. Good. Mirna. Okay, good evening, everyone, and welcome to our fourth CPD event tonight, organized by the UAE iStructI Regional Group. I'm Iman Abisab. I'm the chair of the institution regional group. And I would like to thank you all for joining us here at Harriet Watt tonight, Dubai campus. And tonight's event is hybrid, so thanks to our attendees also who are joining us live on Zoom and YouTube channels. A quick maybe housekeeping notes before we start. There is no fire drill tonight, and should the fire alarm go on, you need to exit from that door, go towards the right, and the exit door will be straight in front of you. It's just a short walk. And our CPD event tonight is entitled Leading Net Zero Steel for Sustainable Construction. And as we all know, the UAE has committed to achieve net zero by 2050. And within this commitment, the UAE has implemented several policies and strategies to achieve this target. And within that, there is a very important strategy around the industry decarbonization roadmap. And that includes also massive carbon reduction emissions across all sectors, including the steel industry. And this is where AGSI fits. So AGSI was the first carbon neutral plant to achieve carbon neutrality in the world. And we have the pleasure tonight to have a talk by AGSI who will take us through the journey on how they have achieved net zero carbon. And for this, we have our speaker, Fuad Ahmad, who is the Business Development Manager of AGSI. Fuad is going to introduce us to AGSI strategies and policies and how they have come up to achieve this important certification or standing. Fuad is a mechanical engineer. He's got experience in the construction and steel industry. He specializes in business development, project planning, and technical compliance. A quick note regarding the content of the CPD. We confirm that to our best knowledge, any copyright permissions and any necessary information disclosure approval have been obtained by the presenters for all the materials that you're going to see tonight. We will take any questions after the presentation. The presentation will run for around about 40 minutes, and you can pop in your questions in the Zoom or in the YouTube channel, and we will take them at the end. Before I hand over to Fuad, I wish to thank our sponsors this year, Hempel, who is our gold sponsor, a supplier of intumescent and fireproof durability paint, as well as AGSI, who is our silver sponsor and is going to present tonight. I think that's it, and over to you, Fuad. Thank you.
Thank you very much, Engineer Iman. Thank you for the warm welcome, and thank you for the opportunity to present ourselves to your esteemed organization and to people watching currently online and available here in the room. Over the next 45 minutes, I'll be taking you on a detailed journey on how AGSI became as it is today. We'll cover our steelmaking processes, for the advanced technologies that make carbon neutrality possible, our contributions to green building standards like LEED, and structural performance of the steel products. Whether you're a practicing structural engineer or a student preparing to join the profession, I hope you'll walk away from this talk with a deeper insight into how structural materials like steel can shape a more sustainable built environment. So I would like to start off with an interesting fact in this industry. The built environment alone contributes to 40% of global gas emissions. Of this, 27% comes from building operations like cooling, heating, and lighting. Another 13% is from materials and construction activities that we refer to as embodied carbon. Embodied carbon is becoming the next frontier. Materials like concrete, aluminum, and steel, which we use extensively, are responsible for over 23% of total global emissions. Reducing their impact means fundamentally rethinking how these materials are sourced and produced. AGSI took the opportunity to develop the conventional steel due to its exceptional properties into low carbon steel that makes measurable differences. Before I go in deep into our company's facts and offerings, I'd like to start historically on how AGSI became as it is today. Since our commercial operation in 2016, we have been a steelmaking plant that produces only steel billets locally in the UAE. This gave us an advantage at the time where we're the only steel makers making steel billets and supplying to the big markets, big players in this market. Before, they used to purchase these billets from outsourced abroad. Then by, let's say, 2021, we decided to include our own rolling mills for making rebars and sections. And let's just say, from that time and just under 2 years, AGSI went from being a new entrant in the steel industry, to a first carbon neutral steel plant. So just to sum up our journey, we joined the Sustainable Companies Pledge, the UAE Sustainable Companies Pledge, being certified twice for lowest carbon emissions in the MENA region, participation in COP28 and Climate Week NYC as a net zero case study, becoming one of the chosen champions of the Industrial Transition Accelerator, focused on decarbonizing hard-to-abate sectors like steel, cement, and heavy manufacturing, developing collaborations and partnerships with big players in the industry, like Aldar, Sea Institute, and soon many more to follow. This journey reflects our belief that industrial growth and sustainability are not mutually exclusive. With the right technologies and commitment, it is possible to scale green manufacturing in high-impact sectors. Now we go to the key facts about AGSI. We are currently the largest private sector steelmaker in the world, in the UAE, apologies. What sets us apart is our fully integrated production model. We don't just produce steel. We manage the entire value chain, from scrap collection and processing to billet production, and finally to rolling to rebars and sections. This integrated approach has several technical and sustainable advantages. First, it reduces logistics, complexity, and associated emissions. Second, it allows us to control quality at every stage, which is particularly important when producing precision profiles used in load-bearing structural applications. And third, it positions us to scale up innovation quickly, such as implementing carbon-neutral manufacturing at the system level. We currently produce around 600,000 metric tons of steel annually, 360,000 of rebars, and 240,000 of sections. But by the end of 2026, AGSI would reach to a point it would make 1.2 million metric tons annually. This is significant, not just from a capacity standpoint, but because every ton of that increased output will be produced under net zero emission standards. This means that there will be greater access to sustainable steel for high demand projects across infrastructure, real estate, and industrial sectors. It's worth noting that steel is the most recycled material in the world, and AGSI is ensuring that even new steel is produced sustainably. At the core of our sustainability strategy is recycling. AGSI currently processes 750,000 metric tons of recycled steel. Some people call them scrap, making us the largest recycler in the UAE. Since steel is infinitely recyclable, it can be reused without any loss of its mechanical properties or structural performances. By sourcing 100% of our raw material from local scrapyards, we eliminate the need of mining iron ore and reduce transportation emissions, which are two major contributors to embodied carbon. The result is a recycled content steel with a carbon footprint that is among the lowest in the world. One of the milestones we are most proud of at AGSI is our recognition as the first carbon neutral steel plant in the world, certified by DNV, which is one of the most respected independent assurance bodies globally, especially for hard to abate sectors like steel. So just to reiterate, AGSI produces the following: billets, rebars, and sections. All products are tailored to meet the international codes and standards to be in line with the project requirements when it comes to mechanical and structural properties and available grades and sizes. So let me go in one by one. How billets are made, first of all. In AGSI, there are around 6 main procedures that is important for producing the low carbon steel billets prior to rolling. We begin with the 100% locally sourced steel scrap, which is brought to our facility in large volumes, minimum 50,000 tons per month happening. Once the raw materials are received, it enters the scrap yard where it is unloaded and sorted based on the type and composition. Processed using specialized machinery like shears, shredders, and magnets to meet furnace stock specifications. On average, we process around 1,200 tons of scrap per day to feed our steel melting operation. This ensures that there is consistent melt chemistry and energy efficiency in the furnace. Third is the most important part. The prepared scrap is then charged into our induction furnace technology. We operate a total of 4 furnaces, each with 30-ton capacity and 12 megawatt power rating. Unlike traditional blast furnaces or electric arc furnaces, induction furnaces do not burn fuel. Instead, they use electromagnetic induction to generate heat directly within the metal. Thus, no use of oxygen will be required, as it will be fully operational through electricity. This results in no CO2 or other greenhouse gas emissions emitted whatsoever, more precise control over melt at temperature, lower heat loss, and faster startup times. This is the cornerstone of AGSI's net zero strategy: clean, efficient, and scalable steel melting. Now, just not to confuse you, we don't usually consider this as a necessary stage, but it might be as a last resort in case the scrap processing does not come out as it should be, which is a very rare case in our end. Once the scrap has melted and there are still some minimal impurities, it moves to the oxygen blowing stand, where the molten steel is chemically adjusted accordingly. This process ensures that the molten steel is free from impurities that are beyond our control. Originally, once the steel has been melted, the molten steel goes into the ladle refining furnace, also known as LRF. In this stage, additional alloying elements will be added to fine-tune the molten steel's mechanical properties in order to meet the grade specification requirements and standards. The LRF allows us to meet tight compositional tolerances and improve steel cleanliness, both of which are critical for applications like seismic grade rebar or heavy structural beams. Once the steel is refined, it is cast into billets using our 3-stand continuous casting machine. Its key features include electric ladle turret for precise pouring, a 13-meter radius bend for strand control, and automatic gas cutters for accurate billet length. So basically, liquid steel at around 1,500 degrees Celsius is rapidly solidified into billet form at around 500 degrees Celsius. This minimizes segregation, improves surface quality, and increases productivity. The hot billets are then transferred to the cooling bed, where they stabilize in ambient air. This prevents internal cracking or stress accumulation. Once cooled, billets are labeled for traceability, inspected for surface and dimensional quality, stored in the billet yard, or directly transferred to the rolling mill. Then these billets are now ready to be rolled into rebar or structural sections, both of which we'll explore in detail shortly. So just some insights before I move in further. The induction furnace and LRF combo ensures both energy efficiency and metallurgical precision. Our billets are tested for macrostructure, composition, and inclusion rating before dispatch. This method eliminates the coke-based reduction seen in blast furnaces, meaning AGSI billets are free from fossil fuel-derived carbon. Because of these practices, our billets are ideal for green building, LEED certified projects, and high-performance civil infrastructure. Now let's delve into the rebar mill process. The first stage is the reheating furnace. Here, the cold billets are fed into a high temperature furnace where they are heated uniformly to about 1,100 degrees Celsius to 1,250 degrees Celsius. The purpose of this is to soften the billets and make them suitable for plastic deformation. Uniform heating is crucial because not just for rolling efficiency, but also to prevent internal stresses or non-uniform grain structures, which could compromise the final mechanical properties. Once the billets exit the furnace, they enter the rolling mill stands. These are multiple rolling passes arranged in sequences of roughing, intermediate, and finishing strands. This is where the billet's cross-section is progressively reduced. At AGSI, our rolling mill is designed for high throughput and dimensional accuracy. The billet is transformed from a solid rectangular profile into the round ribbed profile of a rebar. And this happens at speeds that can exceed 15 meters per second. The rib patterns are essential for bond strength with concrete. They are rolled directly into the bar during the finishing stand phase. Rib geometry is precisely controlled as per international standards such as BS 4449 or ASTM A615. Immediately after the last rolling pass, the hot bar enters the quenching box, where high pressure water jets cool the surface rapidly. This process, also known as the QST, or also known as quenched and self-tempered, creates a hardened outer shell while the core remains hot. As the bar continues through the cooling bed, the retained heat in the core tempers the outer layer, resulting in a composite microstructure. This gives the rebar both high strength and ductility, ideal for seismic performance and crack resistance. So like the billet process, the next stage is the cooling bed, where the bars are laid out in a controlled pattern and allowed to cool down naturally in ambient air. This ensures straightness, grain refinement, and temperature equalization across the cross-section. Once cooled, the rebars are transferred to the cold shear machine. Here, they cut into fixed commercial lengths. Usually 12 meters through custom lengths are also possible depending on the project requirements. After that, it goes to the bundling station where you bundle the ready-made rebars together, tie them all up into small bundles for logistic purposes, and then they'll be ready for dispatch. Now, just to show you the insights of this process, first of all, the QST treated rebars offer superior weldability and lower carbon equivalency compared to traditional microalloyed rebars. Our rebars undergo routine tensile, bend, rebend, and fatigue tests as per international standards. We can produce grades up to 600 megapascals of yield strength, suitable for high-rise and infrastructure. This is very important because it supersedes the standard requirement. And this is because our process is fully reliant on 100% recycled scrap and zero carbon inducting melting. We don't just do these tests internally. We make sure that our findings are backed up by certified third-party agencies before commissioning to our consumers. This is an official comparison table of our full range of rebars detailing that we comply and supersede with the standard requirements. As you can see here in the mechanical properties section, our rebars are much stronger than the conventional steel. Last but not least, we'll talk about the section mill. It is relatively the same as of the rebars, but has some extra processes due to its complex design. It goes to the reheating furnace at the beginning, the billets will go to the reheating furnace, and the same application applies. After the reheating furnace, the billet enters the reversing mill. Unlike a continuous mill, this system consists of a set of rolling strands where the billet is passed back and forth multiple times, with the roll gap adjusted in each pass to achieve a desired shape. This multi-pass reversing process allows for a gradual and controlled reduction in thickness and width, which is especially beneficial when rolling complex profiles. This also gives us flexibility in roll configurations and allows us to roll both symmetric and asymmetric sections. After the versing process, the semi-finished profile is entered to the finishing mill. Here, the geometry is finalized and surface finishes are improved. At this stage, the exact dimensions of flanges, webs, or edges are refined to within millimeter level tolerances. What makes this step special at AGSI is the capability to change roll sets quickly and accommodate different section profiles. The next step, which is the same as in the rebars, is the cooling bed, where the finished sections are laid out under ambient air. Once cooled, the profiles are passed through the straightener. This machine uses a series of adjustable rolls to correct any remaining curvature or camber in the product. Straightness is critical, especially for structural applications, and the AGSI plant is capable of achieving tolerances well within the desired standards for dimensional accuracy. After the straightening, the profiles are transferred to the bend saw, where they cut into fixed commercial or project-specific lengths. This differs from the cold shear in that the saw blade offers cleaner cuts, especially important when the end condition needs to be smoother for welding or when used in exposed structural framing. After cutting, of course, the material will be ready and it will be done. It will be going for the bundling station and ready for dispatch. So some insights on the section mill. The reversing mill setup is particularly efficient for low volume or custom profile production, ideal for infrastructure, OEMs, and modular steel systems. AGSI uses low carbon steel grades with high weldability and ductility, making them suitable for seismic zones. Our rolling is backed by mechanical testing like Charpy impact, UTM tensile, bend, and macro etching to verify grain structural integrity. Sustainability is embedded into this process where there's zero fossil fuels, zero carbon melting, and energy recovery systems in the furnace. Now, before I end this topic on the sections, just the slides details are on the sections that we offer exactly and some of its applications. So in general, we have the IPE, IPE-AA, HEA, HEB, UB, and UC profiles. The IPE and IPE-AA beams are ideal for floor beams, second framing, and general structural use. The AA series is lighter and used where weight savings are critical without sacrificing rigidity. The HEA and HEB beams are wide flange beams. HEA is optimized for medium load structures, while HEB offers higher load capacity structures, specifically in transfer beams and bridge decks. UB, or universal beams, are taller than they are wide. These are ideal for spanning applications like bridge girders and long span trusses. Universal columns, they are nearly square in dimension and are used as vertical load-bearing members in buildings and towers. We also offer the GIS profiles, which stands for Japanese Industrial Standard, and this caters to regional market preferences and specialized architectural needs. So every section produced undergoes quality assurance tests, including ultrasonic testing, tensile, and bend tests. To guarantee this happens to guarantee performance with regional and international structural steel codes. Now, this one is just to show you a simplified version of our net zero steelmaking process. First, we have the scrap collection and sorting. Then we have the melting in our induction furnaces. Then comes the refining and alloying of the molten steel. Then the continuous casting into billets. then hot rolling into rebars and sections, and finally cooling and cutting for a final product generation. This process has supported us in achieving a high in-country value requirement due to our local sourcing and production applications which meets the UAE's Net Zero 2050 vision. Just to give you an interesting fact, globally, over 630 million tons of steel are recycled annually. Every ton of recycled steel saves around 1.5 tons of carbon dioxide, 1.4 tons of iron ore, 0.6 tons of coal, and 0.05 tons of limestone. Using recycled scrap reduces energy consumption by up to 74% compared to using virgin iron ore. AGSI processes around 40 to 50,000 tons of local scrap per month, enough to build the steel structure of a Burj Khalifa-sized tower every 45 to 50 days. Our carbon neutrality is the result of real, measurable reductions in process emissions. As mentioned before, the key to this lies in our use of the induction furnaces, which operates without fossil fuels, unlike traditional blast furnaces, which rely on coke, which is a high carbon fuel, to reduce iron ore into molten iron. Because we rely exclusively on 100% recycled scrap and use renewable electricity for minimal offsets, we eliminate Scope 1 and Scope 2 emissions from the production cycle. Sorry. These efficiencies are verified annually with our emission levels confirmed at 0 tons of CO2, equivalent per ton of crude steel made. This is a benchmark achievement in the global steel industry. Now, this slide is very important because it shows you the difference between the available furnace technologies in terms of CO2 emissions released. So at the top is literally our steel making method, visually represented. And as you can see, very low CO2 gases emitted at the end of the production phase in comparison to the others. Our technology is considered a secondary steel making process where the raw materials are not made from scratch. Another method of secondary steel making is the EAF route, or the electric arc furnace route. True that this method will use 100% recycled steel scrap, but the arc furnace will require oxygen to provide the heating and efficiency needed for a well-produced finished product. Primary steel making is still being used, but not recommended, especially in this region. They would need to extract molten iron from iron ore, and this requires huge amounts of energy and oxygen, resulting in immense loads of emissions. As mentioned before, we commissioned independent audits by the NV to validate our net zero claims. These audits were conducted in line with two gold standard protocols, the ISO 14064-3 for greenhouse gas accounting, and the PAS 2060 for carbon neutrality certification. These certifications confirm that our operations from raw material input to final product produce zero net emissions. What's even more important is that these reductions are real, measurable, and replicable, not based on future promises whatsoever. That's critical for projects that want to secure sustainable financing or meet ESG reporting thresholds, especially in international developments or LEED certified buildings. So just to show you our other product quality conformity certifications in line with the local requirements for projects in the GCC and even the UAE. Now we go a bit about ESG. Our model follows the principles of infinite circularity in steel production. We use 100% recycled steel waste, avoiding virgin ore extraction. All waste and byproducts like mill scale, slag, and fumes are reused or recycled into industrial inputs like cement. Most importantly, our electricity supply is powered by clean and renewable energy, which is a critical enabler of low emission steel. This means specifying material that doesn't just perform mechanically, but also contributes positively to your project sustainability and life cycle assessments. ASGI's strategy is not just about carbon reduction, it is a complete environmental, social, and governance transformation, aligned with the UNGC's or United Nations Global Compact Sustainable Development Goals and the 2030 Agenda. Now, some of these goals include, but not limited to, industry innovation and infrastructure, responsibility of consumption and production, climate action, clean waters and sanitation, affordable and clean energy, and partnerships for the goals. And these involve collaborations with climate groups and industrial platforms. This global alignment gives added assurance to international consultants and developers looking to source from socially responsible suppliers. Now, how are we contributing to LEED? Why sustainability for buildings? That's the main question here. Sustainable buildings reduce energy and water use, cut carbon emissions, and lower operating costs. As a result, they can boost property values up to 26%, increase occupancy rates to 96%, and tap into a fast-growing green finance market, while also enhancing brand value and demonstrating leadership in sustainability. Let's now explore the connection between AGSI steel and LEED certification. Steel from AGSI directly supports credits under the materials and resources category. Our recycled content, low carbon footprint, and transparent documentation align with multiple credits. And these are credit 1, the life cycle impact reduction, credit 2, the environmental product declarations, credit 3, the sourcing of raw materials, credit 5, construction waste management. Used in combination with other green practices, our products will contribute to improving LEED scores by up to 4 or more points in the MR category alone. So let's break this down a bit further. For credit 1, which is the life cycle impact reduction, from total 4 options under this credit, our low carbon steel supports the 4th LEED option, which is the whole building life cycle assessment. Using AGSI steel can help earn at least 1 point, especially when a project meets 3 out of 6 impact categories like global warming potential, depletion of non-renewable resources, or acidification. Credit 2, the environmental product declarations. We offer verified EPDs for our products. While a project needs 20 materials to fully earn this credit, AGSI steel counts as one of them and can help earn 1 point. For credit 3, sourcing of raw materials, there are total 2 options in this credit. Our 100% recycled, locally sourced steel supports both of these options, and this contributes to 1 or more points for responsible extraction practices and local sourcing transparency. The last credit, credit 5, from the 2 options available, our fully recycled steel supports the first option of diversion efforts. If the project diverts 75% of waste from at least 4 streams, 2 full points are achievable. In short, AGSI steel is not just structurally sound, it's a material that supports project certification, lowers embodied carbon, and enhances investor confidence in green assets. I give you an example on a LEED certified office, for example, that is about 50,000 meters squared in area. This office, if it uses our steel, it could gain up to 7 LEED points in the materials and resource category and benefit from 26% higher asset value. Before I conclude, I'd like to address some facts on why this matters. The UAE's Baraka nuclear plant in Abu Dhabi incorporated over 100,000 tons of steel. If produced using AGSI's net zero process, it would have saved over 200,000 tons of carbon dioxide emissions, equivalent to taking 43,000 cars off the road for a year. Global demand for green steel is expected to reach 250 million tons by 2040. Another fact is that over $400 billion in sustainable construction projects are planned across the GCC by 2030. Now, to conclude, I'd like to leave you with this thought. Sustainability in construction doesn't begin at the building site, it begins at the material source. And at AGSI, we're redefining how structural materials are made with net zero as our baseline, not our aspiration. From in-house billet production using induction furnaces, to carbon neutrality verified by global standards, and to supporting LEED and ESG goals, AGSI is proud to be your regional partner in building the sustainable skylines and infrastructure of the future. Thank you so much for your attention. I now welcome your questions, and I'm happy to dive in deeper for any you have accordingly.
Thank you very much for a very interesting presentation. You took us through the manufacturing process entirely and the outcomes. You've touched on the ESG goals and including the LEED certification and some aspect of the cost as well. You've mentioned something very interesting in your last words about the journey starts from the beginning of the manufacturing process. And maybe I'll just add to this that the journey for us structural engineers starts all the way from the concept of the project, where we set the project brief, we set the project specification, and this is where we can influence the journey from the beginning on how much materials we put and what sort of material we procure. So thanks again. And I will start taking questions from the audience here in the room. You have the advantage, so make use of that advantage. Any questions here? You've got two advantages. Actually, we have some refreshments at the back as well. Any questions here? I will just come to you.
So you mentioned rebars and sections. So do you do plates as well?
Unfortunately, no, as our furnace is limited to making steel billets, and from these billets we can only roll them to rebars and sections. For plates, it's a different kind of steel, which are flats, and these require special furnace technology or a full production line that it's not within our scope yet. But maybe later down the road, or maybe we will include it.
So, and sorry, second question. You said like you can adjust your manufacturing process to tailor make the sections. So, out of those sections, is there any additional sections which you are planning to include?
It's in talks currently. So far, what we have is the available sizes that I've shown. And with the expansion going on, definitely we'll be including the new sizes and new shapes.
Thank you.
Thank you for the great questions. Thanks. Any more questions from the room? Okay, I will go to the Zoom. And we've got some questions here. The first one from Nagaraju. How much percentage of scrap is used for production of the new steel?
Like I mentioned, I think more than once, our raw material is basically 100% of scrap. Like we gather, we go to local suppliers, vetted suppliers that provide us the necessary scrap material we needed, and we take them to our scrapyard and start the processing to ensure that the furnace only has the processed scrap.
And maybe just a continuation of the question, Fuad, if you don't mind. So 100% steel scrap, is that enough? Is there enough availability of materials to cope with your demand in terms of scrap steel?
Yes, like so far, every month we can say we are gathering like 40 to 50,000 tons of scrap per month. And this has made us like the largest recycler in the UAE itself. So we have partnerships with large yards around the UAE, and they will always we have agreements with them that the majority of the scrap in the UAE will be delivered to us, And we are also approaching like developers and contractors for their projects as well, that whatever waste they have or whatever scrap they have, they would also partner with us, and we would use their quantities as well. And that's about it.
That's excellent. Feel free to read the second question.
Second question from Sangeeta. Elongation is less than 14.5%. Is this allowed for use in seismic zones? I will have to double check on that, as I believe it should be fine, but I will have to double check on that, yes. But so far, like based on what we've tested internally and also certified through agencies, that in terms of strength, yes, it is meeting the requirement and even a bit better. In terms of the elongation, it should be also compliance.
And maybe Fuad, we can come back to Sangeeta. She can reach out to you if we share your contact details at the end and come back to her with a more detailed answer. Yeah, thank you. No more questions on Zoom, and I can't see any on YouTube at the moment. Wait, sure.
So I have two questions, sorry.
Go ahead.
So one is continued question from here. So the sections that I saw on the screen are the only sections available currently, or are there more that, or is there a list perhaps?
They are currently available in our portfolio, yes.
All right, okay. So my second question is related to the lead and the credits for sustainability. So perhaps I can take the slide off from this presentation, maybe. But is there a way that a sub-consultant who is into sustainability can reach out with more points, perhaps, so we could have a talk together in terms of how we can acquire these to initialize or, from the concept stage going on to the DD on projects and, add value to a project?
That's a really interesting question. So as I mentioned, from our steel, yes, we can support in approving the LEED certification for the project. But also with the help from the consultant side, he would also need to check on the other materials, because at the end, in this category itself, it's not just our steel that needs to improve the score of the LEED. It's the other materials that fall into it as well. So let's say for the first credit, we give you the 1 point needed, but he would need maybe 3 or 4 points more. He would need to check the other materials that is part of this credit to meet this requirement. So I remember I did this training about it, and they showed us like you can say a tag of the total LEED requirement for the building itself. And I believe for the first category, it should be minimum 6, if I'm not mistaken. But yeah, like this will be a collaboration with not just our product, with the other products involved in the project as well. But yes, like we can, if he would, the consultant himself would sit with us and the others, manufacturers or suppliers, then it can be collaborated in this manner. I hope that answers the question.
No problem, thank you, that's all right.
Great question indeed. In fact, we often find that with little impact or no impact sometimes on cost, we can gain some credits easily if we start planning from the beginning and engage with the supplier, such as steel manufacturer, for example. Yeah. Good question. Thank you. Any other questions? We've got one more on Zoom. We're gonna read it because YouTube don't see it. Yeah.
You are producing the steel with electric furnaces, but using of electricity is also carbon emission prone to environment. Instead, we've to go for alternate materials instead. What's your insight? It's true, like our induction furnace is purely electrified, but what makes it different than the other electric furnace or the arc furnace is there's no use of oxygen on it whatsoever. Our electric furnace is purely powered by electromagnetic induction, and without the use of oxygen, there's no emissions coming out of it whatsoever. Electric arc furnace, it doesn't use electromagnetic, it uses a electrode process that still requires oxygen rather than the induction furnace. So Yeah. If you are using 1 ton scrap, how much ton it will result into new?
Any loss, waste.
I mean, no, because we like to consider ourselves an epitome of circular economy. So whatever uh, recycled steel we use and pump into the furnace, the generated waste from the production phase will be reused again in a new batch of production. So mentioned the furnace capacity is minimum 30 tons. So we usually pump in around, let's say, enough amounts to produce at least 30 to 35,000 tons per month of steel. This is currently our capacity. And by the end of the year, we'll reach about double that, which is like 70 to 75,000 tons a month.
Firstly, thanks for the presentation. Very useful and knowledgeable as well. I have a couple of questions, maybe three. One is there any difference in cost because of your approach to manufacturing itself compared to your competitors? That's the first question. Do you want to answer with
That
each
is a
question?
very good question. The amount of times we have been asked this question, and we always love to answer that since we are providing a premium product, our price is always as per the market. So whatever the market price comes up, and as some of you or probably all of you are aware, the biggest player or the biggest competitor for us is Emirates Steel. And when they generate the prices per month, once they generate it, we follow accordingly or even lower, even much lower than them. So yeah, for price as per the market.
That's good then. The second question was you said you produce rebars also.
Yeah.
So is there any specific diameters you produce, or you cover all the diameters from 10 to 40 mm?
We currently produce from 10 milli, 12, 16, 25, 32, and on demand can be 40 as well.
Okay, so you pretty much cover the entire
Yes.
range. So that's good. The third question is generally, I think your main market is the contractors or the developers where you need to approach and get them to buy in.
Yes.
But most of us here are consultants, I think. So as a consultant, when you approach a consultant, how do you think we can influence this decision of going with a net zero steel compared to any other?
See, thank you for that question. Yes, at the beginning when I started and when my team started in this company, we wanted to market ourselves, spread our brand in projects because whoever we met before, none of us heard of us, and we're the only ones that are certified as net zero in the region. So we approach consultants so that they can know about us, know what we do, and how we can benefit the projects. But we don't want them to specify AGSI. We want them to specify net zero steel. Because now the UAE's vision is net zero. And we believe that if all buildings or projects that are upcoming, our support or our material can help these buildings meet the vision. So currently now, we want to get as much approvals as possible for all upcoming projects. And what we're finding out recently that contractors are the ones that are supported. But you know, contractors, they only care about three main things: price, payment, and availability. However, there are some which we are currently close to partnering with them, like Trojan Contracting. They are focusing on sustainability, and they have supported us currently with getting some approvals in Abu Dhabi. And with our partnerships with Aldar also, it's helping us as well. So we still approach consultants because we want them to know the importance of net zero. And if the requirement of a building does not require full sustainability, it's fine. At least sustainable or net zero specification should be implemented in all buildings for a specific amount.
Thanks.
Thanks, Ajit. One more question.
I saw a slide showing mechanical strength of a profile. It was excellent. Required is 275 and it achieved 344, maybe 340 plus. So what are other positive things you found during your production, which is excellent compared to the other steels?
The strength of the steel itself. Yeah, like if you noticed in the comparison table, I'll probably show, for the rebar specifically, as per the standard, minimum should be at least 500 yield strength and sometimes 540 tensile strength. We are way over that. Like we almost can reach in this minimum amount at least 600, which is very, very well known. And this one, like we try to convince people, or when we meet people, they always believe that using 100% steel recycled material makes the material weak. But in fact, no, it does not. And that's why we are mostly proud of.
Thank you.
I think there's one
I think
more
there's
question.
one on YouTube as well. Yeah, we can take the Zoom first.
Okay. Other steel suppliers, EPD, says that the steel is with 95% recycling materials. How advantageous is not AGSI is achieving the credits compared to them? So here, I'm not sure if they mean 95% of recycled raw materials or recycled content. Now, in our case, yes, our raw material is basically 100%.